Okay, this is exercise 8.1, which is translating arguments into quantifier logic or predicate logic. So we've got premises, conclusion. All we're doing in this exercise is translating. We're not doing any derivations or anything like that yet. So we have to provide a symbolization key. I think for UD we're gonna pretty much stick to everything, but if it's not, and maybe not, but we'll do that as we go. So the UD is the domain of discourse of what you're talking about. So let's just say everything for this one. So we need predicates. So we have X is a dog. Actually, since we have two C words, we'll use second letter. Actually, the second letter is the same too. Okay, so TX equals X is cute, and DX, we already have DX. LX equals X is cuddly. And it looks like all the predicates we have, but it's really important not to use the same letter for two distinct predicates. All right, now you can mostly go by sentences for these. So the first sentence is dogs are cute. Now you notice there's no quantifier word there, but it's certainly implied. When somebody says dogs are cute, they mean all dogs are cute, right? It's like if you say whales are mammals, you're implicitly saying all whales are mammals, not just some. So you have to look at the context, all right? But in this case, it looks like universal quantifier. If X is a dog, then X is cute. All right, that's premise number one. Next premise, take them one at a time. All right, it's easier if you break big problems down into smaller problems. So second, dogs are cuddly. Again, the implication there is all. So universal quantifier, if X is a dog, then X is cuddly. Now, therefore is a conclusion indicator word. And so our conclusion is dogs are cute and cuddly, again with the implication of all X, X is a dog, then, parentheses, X is cute and X is cuddly. We can use a bracket for that outside parenthesis just to make the sentence easier to read. And we need to set apart the premises from the conclusion, right? Horizontal lines, the easiest way to do that. That 3 dot symbol works, except it's not really accessible on the keyboard. You can use, sometimes I use a backslash, but in some way you have to distinguish the premises from the conclusion, make it clear which is which. Okay, that was number 6. The homework for this is 1 through 5, so that's why I'm doing 6 through 10. Just going to make this a little bigger. All right. So 7, we have all tall people who have taken a logic course are super cool. Penelope is tall, but she has not taken a logic course. We have to conclude that Penelope is not super cool. So again, we have to conclude that is conclusion indicator. So it looks like premises, and then conclusion at the end. Now in this case, we are just talking about people. So we could set the UD to be all people instead of all things, which will allow us to skip having a predicate specifically for people. So we have TX is X is tall, LX is X has taken a logic course, and SX is X is super cool. All right. So since we set the UD to be all people, we don't need a specific predicate for people. If we set the UD for everything, then we would need a predicate for person or people. All right. So that's one of the ways that setting the UD for people is helpful. And also, like, there's nothing we're talking about in this argument that's like a dog or an animal or a rock or a house or whatever, right? It's the thing we're talking about here is people, right? Only people take logic courses, etc. Okay, so let's do premise one. All tall people who have taken a logic course are super cool. So we're saying all is universal. So if X is tall and X has taken a logic course, then X is super cool. All right. So for all X, if X is tall and X has taken a logic course, then X is super cool. Next, Penelope is tall. So that's just we didn't set a letter. Remember, lowercase letters for subjects. So lowercase p for Penelope. So Penelope is tall would be TP, but, which we know is a conjunction, she has not taken a logic course. So it's not the case that Penelope has taken a logic course. So we have to conclude, that's the conclusion indicator, Penelope is not super cool. So it's not the case that Penelope is super cool. And again, we want to distinguish or differentiate the premises from the conclusion in some way to make it clear. And that's it for number 7. Now remember, sometimes people get confused. They're going along, they're using quantifiers, and then they come to a sentence like this, and they go, oh, I must need a quantifier in there, right? But you don't. Quantifiers are for words like all, some, none, etc. If you just have a singular subject like Penelope and a predicate being applied to that singular subject, then there's no quantifier needed. It's just TP. Penelope is tall. Okay, number 8. If everyone is sad, nobody is happy. However, Pharrell Williams is happy. Therefore, it must not be the case that everyone is sad. So again, pretty straightforward. Premise. Therefore is a conclusion indicator. So conclusion. All right. Now this one we have. This can get kind of tricky because on the one hand you use a conditional within a universal quantifier sentence, but in this case the antecedent of the conditional is itself a quantifier sentence. So it's going to look like this. Everyone is sad is for all X. And again, well, oh yeah, we need our. So UD, let's do for all people. Since we're talking about people here. SX equals X is sad. HX equals X is happy. And we need P for Pharrell Williams. So again, only use one single lowercase letter for that. Don't use PW or something like that. So it looks like that's all of our symbolization that we need. Okay, so everybody is sad for all X. X is sad. Right? Since we already specified people, we don't need a predicate for people. I mean, here's the difference. If you set the UD for everything, then you would need PX equals X is a person, right? And then you need this to be for all X. If X is a person, then X is sad, right? So you can see how by setting the UD to a smaller domain, it makes your sentences less complicated, right? And again, I mean, everybody generally means people, so we're talking about people. So you can do it either way. Either of those ways is perfectly fine. But again, if you're only talking about people, there's no need to set the domain to talk about everything, right? So we'll do it like this and simplify our. Okay, so that means we have for all X, SX, right? But that's only the antecedent of the conditional, right? The consequent then is nobody is happy, right? So remember, for none, you can do it like this, where you say for all X, it's not the case that X is happy, or alternatively, you could do it like this. there do not exist any people that are happy. I'm going to stay with this since nobody is a universal claim, so I like it to use the universal quantifier. All right, if everyone is sad, then nobody's happy. However, Pharrell Williams is happy, so next premise is just HP. Remember, if you have a singular subject with a predicate being applied to it, no quantifiers are necessary. Conclusion, therefore, it must not be the case that everyone is sad. So it must not be the case that is negation, right? So we need to negate the sentence, everyone is sad, in our conclusion. So the sentence, everyone is sad, is just all x, sx, right? But again, it must not be the case that. Right? So now we need to distinguish or set apart the premise from conclusion. Again, horizontal line works fine. And that's number 8. Okay, so let's go down the page here. Number 9, only rich people can run for president. Furthermore, only rich people can run for Congress. Consequently, Melissa cannot run for president or Congress since she isn't rich. Now, this one's a little tricky because it has one of these things where it ends up jamming a premise in at the very end, after the conclusion. So what we have here is premise, 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 conclusion. And remember, since is a premise indicator word, right? And this is giving another reason or another premise as to why you should believe this conclusion. So be careful. It's not always going to be straightforward premise, premise, conclusion. All right. So again, we're talking about we're talking about people. So let's make our UD all people. We have Rx will be X is a rich person. We'll have PX equals X can run for president. CX equals X can run for Congress. Okay, and then we need, we need Melissa, right? So lowercase m for Melissa. All right, so first premise, only rich people can run for president. Now remember, only is different from all. If we were going to do all rich people can run for president, it would look like that, right? That says for all x, if x is rich, then x can run for president. But only and all are different. And the basic way to differentiate them is to flip the order around the conditional. So instead of Rx and PX, you got PX then Rx. So for all x, if x can run for president, then x is rich. That's the same thing as only rich people can run for president. Okay, so don't forget the difference between only and all. Next premise is the same. Only rich people can run for Congress. Again, if we said all rich people can run for Congress, it would look like this. But again, we don't want to say all rich people. We want to say only rich people. So again, we're going to flip the order. Put the C here, and we put the R here. Now again, we have to remember our other premise, which is at the end, which is she isn't rich, meaning Melissa. So not the case that Melissa is rich. And now our conclusion, Melissa cannot run for president or Congress. So it's not the case that Melissa can run for president. And it's not the case that Melissa can run for Congress, right? Or, cannot run for president or Congress. So that could go either way. You could either have it as the way I have it, a conjunction of negations, or you could have it like this, neither nor, right? It's basically saying she can neither run for president nor for Congress. So either of those is acceptable as the conclusion. Right, so again, be careful. This one's a little tricky because it slides that extra premise in at the end. But otherwise straightforward. Okay, last one, 10. Some college students work hard. Furthermore, anybody who works hard will do well in life. Consequently, if college students work hard, they'll do well in life. let's set the UD for all people. See, X is a college student. WX equals X works hard. And LX equals X does well in life. We don't have any singular names in this one, so it's all quantifiers. Okay, some college students work hard. Some X is a college student and X works hard. Remember, for the existential quantifier, you're generally going to use the conjunction. Whereas a universal, as we've seen, you're going to use the conditional. Okay, so that's premise 1. Premise 2, anybody who works hard will do well in life. So for all X, if X works hard, then, then X will do well in life. So again, make sure you don't use W for both works hard and does well in life. And again, this is anybody, so it's a universal. And since we set the domain for all people, we don't need a distinct predicate for people. Consequently, that's a conclusion indicator word. If college students work hard, right? So for all X, if X is a college student and X works hard, then they'll do well in life. Put brackets around that. Okay, don't forget to separate your premises from your conclusion, and that's it. Right? So some college students work hard. Some X, if X is a college student, X works hard. Anyone who works hard will do well in life. For all X, if X works hard, then X does well in life. Consequently, if you're a college student who works hard, CX and WX, you will do well in life. All right. Okay, that's it for these. There's a couple problems in 8.1 that you want to avoid because they use some of the stuff from section 7.4 and 7.5 that we didn't go over, especially numbers 11 and 12. Although you should also probably skip number 5, I think. You also might use that. So, well, 5 is a sign, so we'll see. I think you can do 5 without the stuff from 7.4 and 7.5, but I'll talk about that in the discussion boards. All right.